Functions of the form y equals c times e to power k times t, where c and k are the constant and the independent variable t represents time, are often used to model population growth and radioactive decay. The t is represent the time and c and k are constant. Note that if t equals 0, then y equals c. If t equals 0, y equals c to power e times k to power 0. So e to power 0 is 1, so this is c. So the constant c represents the initial population or initial amount. The constant k is called the relative growth rate, okay? So here k equal to relative growth rate, and c is the, maybe we can say c is the initial population. Suppose that y equals c of kt models the population of a country where y is the number of the people and t is time in years. If the relative growth rate is k is equals 0.02, let's use this color. So relative point is 0.02, then at any time t, the population is growth at the rate of 0.02 y persons. That is 2% of the population per year. So our function will be c at the beginning. If you know the population, this is, maybe we can use the c naught, c0, etc. Okay, so c e to power 0.02 t. We say that the population growth population is growing continuously at relative growth rate k, to mean that the population y is given by the model y equals c e to power x e to power e kt. You can find some example in your textbook related to the population problem. In the lecture, in class lecture, I will solve a question related with this situation. But for you, the most important concept is compound interest. So, compound interest. The fee paid to use another's money is called interest. It is usually computed as a percent, which is called the interest rate, of the principal over a given period of time. If at end of a payment period, the interest due is reinvested at the same rate, then the interest earned as well as the principal will earn interest during the next payment period. So interest paid on interest reinvested is called compound interest, and may be calculated using the following compounded interest formula. Now I will explain this formula to you. A equals P times 1 plus R over M to power M times T. This is very important formula for you. Here, P represents the present value. So a principal or present value. present value. A principal P is invested at an annual rate R. So R is annual interest rate. This interest rate has to be expressed as a decimal. Okay, what I mean? For example, your interest rate is 5%. So R is 5/100, which is 0.05. If your interest rate is 25%, R is 25/100, which is 0.25. If A is 1.2%, your interest rate is 1.2%, R is 1.2/100, which is 0.012. This point. So rate R compounded M times a year. So M is the number of the period during a 1 year. Okay. So M, how can I well define? M, the number of the period in a year. What is the period? I mean, for example, you invest your money, your principal, monthly. So there are 12 months in a year. So M is 12. Okay. So let's talk about the M. Period. So the number M. If this is monthly, M is 12. If this is daily, M is 365. If this is weekly, this is 52. If this is bi-monthly, this is 6. Okay. Then what is the A? And the remaining is the A, capital A. A is the future value, is the amount. Okay. So A is amount. Which is future value. As a result, this formula is very important for you, and for given R and M, the amount A is equal to the principal times by the exponential function, this is base B, to power M times T. Okay, B is this one, and the maybe B can be considered as a that part with the M factor. I mean that one. If you consider this value is B, A equals principal times B to power T is our formula. So we use the exponential function to describe the compound interest. From this formula also we can observe some other things. If a principal P is invested at an annual rate R and compounded continuously, then the amount is accounted at the end of T years can be given as the following formula. A equals P times e to power RT. Why? Maybe you can recall from the previous record. Here, this approach E, but here we have the 1 plus R over m to power m. So in that case, when m goes to infinity, here m goes to infinity means compound continuously. So 1 plus R over m times m goes to approach to e to power r. Okay, so this value approach to e to power r. 1 plus R over m to power m, which can be expressed as the following form: 1 plus 1 over m over r. Maybe m over r is not a good idea here. Okay, let's keep the r over m, and r over m times r. So we know that this expression, when I'm going to infinity, approach to e, so there is a r factor, so it approach to e to power r. So this approach e to power r. So because of this reason, the component interest formula approach to this one for the continuously compounded case. Okay, so here continuous compound interest formula. How we obtain this formula, maybe I can explain, but it will take a lot of time. So for the people who wonder, we can discuss how we obtain this formula for the compound interest.